dear students, welcome back. Today we are going to discuss the isometric drawings. Isometric drawing is a pictorial representation in which 3D view of an object is shown on a drawing sheet. Here, a transparent cube containing the object is tilted until one of the solid diagonals of the cube becomes perpendicular to the vertical plane, and the three axes, namely x-axis, y-axis and z-axis, will be equally inclined to the vertical plane. Here, isometric view or isometric drawing, the name came from the principle that the equal inclination among x, y and z axes are existing in these figures. The location of the origin of axis may be suitably selected to show the maximum details of the object clearly. Here the point A is the origin and the x and y directions are marked 30-degree inclined like this. And the z-axis is vertical axis. Now, the isometric projection can be directly drawn from the orthographic projections. The two methods used for drawing isometric projections are box method and coordinate method or offset method. In some cases, we are using a combination of this box method and coordinate method. Generally, the front side may be taken to its left, this plane, or to its right. So, if you have the front view and top view in the orthographic projection, we can position the front view in the right plane or on the left plane. And the top view comes here. And the length of this axis are foreshortening to 82%. We will discuss in detail later how this 82% reduction comes in the length along this axis. Projection can be assumed as the object is placed in a transparent box tilted in such a way that the three axes of the box makes equal inclination with the vertical plane. Here you can see the plan of a cube and elevation of a cube. We are drawing a diagonal and making that diagonal 3-C- parallel to XY line. Means diagonal is made parallel to horizontal plane and corresponding plan is plotted. And now we got the 3-C- diagonal like this in the plan. Now I am making this 3-C- diagonal perpendicular to the vertical plane. That is, I am rotating this plan in such a way that this diagonal 3-C- is perpendicular to vertical plane. And now I am drawing the vertical projectors and drawing the corresponding elevation. The axes are equally inclined at 35° 16 minutes to the vertical plane. Now this is the isometric projection of the cube. Inclination of these edges are 30° with horizontal plane. View of that object which is kept inside this transparent box can be called isometric projection. Now we see what are the characteristics of isometric projections. The axis x, y and z forms 120° inclination between one another. That is, if this is x-axis, this is y-axis and this is z-axis, we can see a 120° angle between these axes. The projection is isometric, means equal in dimension along the three axes: height axis, width axis and depth axis. These three axes are proportionally reduced. That is why it is called isometric, equal measures. The sides of the cube and all planes parallel to any one of these surfaces or planes are called isometric planes. All lines parallel to the axis x, y or z are called isometric lines. And all the lines which are not parallel to any one of these axes are called non-isometric lines. The isometric lines are angled at 30 degree. Conventional orthographic projection and isometric projection. We can draw the isometric projection of a cube like this. Now we have the edges A, B, C and D on the top surface and E, F, G and H on the bottom surface. Now I am drawing a 45 degree inclined line which will represent the true length of this edge AD. I am naming that one as DP. And this 45 degree inclined line represents the true length, and this 30 degree inclined line represents the isometric length, which is reduced to 82% of the true length. From triangle ADO and PDO, the ratio of isometric length to true length, that is dA by dP, is equal to cos 45 by cos 30. That is 0.816. That is why the isometric axes are reduced in the ratio of 1:0.816. That is approximately 82%. Since the edges are equally inclined to VP, they are foreshortened to a value of cos 35 degree 16 minute. That is approximately 82%. The capital letters are used for naming the corners of the isometric projection. The hidden edges are indicated by short dashed lines type E or type F, but generally it is omitted to improve the clarity if the number of hidden edges are more. Now I am repeating once again. The isometric axes are AX, AY and AZ, and the lines parallel to this axis are called isometric lines, and the planes representing the faces of the cube or planes parallel to these planes are called isometric planes. Now we already mentioned that the isometric projection should be foreshortened to 82% approximately. Correctly telling, we can say 0.816 reduction comes. For that, in practice, while drawing isometric projection, it is necessary to convert the true length of the object into isometric length for measuring and making the sizes. This is conventionally done by constructing an isometric scale as described below. Before that, you should know what is the difference between isometric view and isometric projection. An isometric view is drawn by taking the true dimensions of the object, and an isometric projection is drawn by taking the isometric scale. The isometric view appears to be larger than that of the isometric projection, because the dimensions taken in the isometric projection are reduced to 82% approximately. Now we can learn how to construct an isometric scale. So first of all, mark a point A, and from point A line AB is constructed. A 30-degree line is drawn and it is named as AC, and a 45-degree line is drawn and it is named as AD. On AD, you can mark the two dimensions, and now you can draw the vertical lines through these points 0, 0, 1, 1, 2, 2, 3, 3 and 4, 4, like this. The divisions thus obtained on line AC represents the isometric length corresponding to the dimensions marked along the AD. Now you can divide the portion between point A and 0 into 10 equal divisions for taking fractions. Simplified isometric scale can be constructed like this. A horizontal line AB can be drawn like this, and after that we can mark 15-degree inclined line from A, can be named as AC, and the actual dimensions can be marked along AB like 0, 1, 2, 3, 4, 5, 6, like that. Now a 45-degree inclined line can be drawn through these points 6, 5, 4, 2, 1, 0, like that. And the portion between point A and 0 can be divided into 10 equal divisions for taking fractions. The isometric lengths corresponding to true dimensions are obtained on the 15-degree inclined line like this. Now we can check how the isometric projection can be constructed from orthographic or multi-view projection. Here you can see the plan and elevation of a cube, and the base coordinates are named as 1, 2, 3, 4. This is the indicating diagram for x-axis, y-axis and z-axis. Here we can attach a corresponding indicator in the plan and elevation. Height is obtained along the z-axis, so z-axis will be like this in the elevation, and x-axis extending to its right, similar to the plan, and the origin point 1 is marked on this horizontal line. Now I have to mark the x-axis and y-axis. X-axis should be 30-degree inclined like this, and y-axis will be 30-degree inclined to its left. 4 can be marked here in this direction after multiplying that one with 0.82. That will represent the isometric length, and the point 4 can be marked along y-axis. Now z-axis is vertical axis. So the height of the object is obtained from elevation. So along z-axis I can take this measurement, multiply that one with 0.82, and I will get this height along this z direction. Now I can join the endpoints and I will get the isometric projection of the object. Hidden edges are marked like this. Now the projection is finished. Now we can see the isometric of plane figures. Here I use the z-axis and x-axis for representing the front side. You can also select z-axis and y-axis depending upon position of the object. Okay. Now z-axis and x-axis are marked, and along z-axis I measure the height of the object. Mark it as BA along z-axis, and along x-axis I can mark B and C. If this rectangular surface is on the top of an object, I can select the y-axis and x-axis like this, and point B as origin. Mark point A along y-axis and point C along x-axis like this. Now I can draw a parallel line CD which is parallel to AB, and another parallel line AD parallel to BC, and I will get the point D. Similarly, we can draw a triangular plane. Here we have the non-isometric line, that is, the line 1, 3 is not parallel to any one of the plane. In such case, I am enclosing this triangle in a rectangle 1, 2, AB. 1, 2, AB is marked on the plane ZX. And 3, which is the midpoint of A and B, can be marked on the isometric view like this. If it is on top view, we can mark the same on Y and X axis, and getting the midpoint of AB and joining point 1, 2, 3, we will get the isometric view of the triangle in the top surface. Similarly, pentagon. Here also non-isometric lines are there, so I am enclosing this one in a rectangle and drawing the projections of this rectangle in the isometric planes and getting these points A, B, C, D and E along these lines 1, 2, 2, 3, 3, 4 and 4, 1. Similarly, we can construct the top view of this pentagon like this on XY plane. The isometric view of a circle appears to be an ellipse. Construction of isometric view of a circle is very important. One of the very common method used is 4-center method. First of all, you have to enclose the circle in a square, and the isometric view of that square is to be marked like this. Now we can mark the point A, B, C, D on this figure. Now we have to draw lines to B, C, A and D like this. These intersecting points and these corner points are the required centers for constructing the ellipse. We can name that one as 1, 2, 3 and 4. Now, taking point 1 as center and 1B as radius, we can draw an arc BC like this. Similarly, point 2 as center and 2D as radius, you can draw an arc AD. Now, point 4 as center and 4C as radius, another arc CD. Similarly, point 3 as center and B3 as radius, we can construct the arc AB. Now we finished the isometric view of the circle in the top view. Suppose the circle comes on the front side. For that, we have to select the X and Z axis, X axis and Z axis, and construct the isometric view of the square. Mark the point A, B, C, D on the figure like this. Now corner points are selected, lines are drawn. Now we got the required center points and name that one as 1, 2, 3 and 4. Now by taking this point 1 as center and 1B as radius, we can draw the arc AB. Similarly, point 2 as center and 2D as radius, we can draw the arc DC, and point 3 as center and A3 as radius, we can draw the arc AD, and finally point 4 as center, 4B as radius, we can construct the arc BC. Now we finished the isometric view of the circle. Now we can see how the top and front views of the given figure can be constructed. For top view, we are selecting the X and Y planes, and the enclosed rectangle is drawn in the isometric view. Now here we have a portion of the circle. Now the curved portions can be constructed like this. Get this intersecting point, and in this intersecting point as center, we can easily draw this curve. And on the other end, we can draw a line from this corner to the midpoint of this side, and another line by joining this corner to the midpoint of this side. Now we can have the center point, this one, and we can construct the arc. Now we can draw the tangent to the two curved portions and join the other points together. We will get the top view of this. Similarly, for front view, we can select the x-axis and z-axis, construct the rectangle, divide that one into two equal divisions, and join the corner to the midpoint of this. Similarly, corner to the midpoint of this side. Draw an arc by taking this point as center and this length as radius. Similarly, for the other half, you can join this corner to the midpoint of this opposite side and this corner to the midpoint of this side. Take this intersecting point as center for constructing the arc on that side. Now we can easily join all these points together to finish the drawing. In all these cases, what we have to do is enclose the given figure in a rectangle and draw the isometric view of the rectangle first and identify the corresponding points in the isometric view. One thing you have to remember is that for drawing the isometric of circle or semicircle, use rhombus method or 4-point method, and always construct rhombus of sides equal to the diameter of the circle. Okay. Now the isometric view of base of a pentagonal pyramid on horizontal plane will be like this. Top view is constructed by taking x axis and y axis. Draw the pentagon, enclose that one in a rectangle, then you have to start the isometric view by taking the x and y axis 30-degree inclined like this. Now we can draw the isometric view of a pentagonal pyramid resting on horizontal plane. First of all, we have to construct the base like this. Then you have to identify the midpoint of the base. After getting the midpoint, you have to mark the height of the pyramid along the z-axis. Get the apex point. After getting apex, you can join the lateral edges like this. We can finish the drawing by selecting suitable line types for representing the hidden edges. Okay. Now the isometric view of a pentagonal prism laying on horizontal plane. Here we can start with XZ plane on which the pentagon can be constructed. For that, first of all, I am enclosing the pentagon in a square. Now the corner points of the pentagon A, B, C, D and E are identified on these sides, and so the length of the pentagonal prism is marked in the Y direction. These N points are connected together by using suitable line types. We can finish the drawing. Similarly, the isometric view of a hexagonal prism standing on horizontal plane. We can start from the base. The hexagon at base is constructed first. Then the height of the hexagonal prism is marked in the z direction like this. Joining the endpoints of these lines, we will get the isometric view. The hidden edges are marked in dotted line. Now, the cylinder lying on horizontal plane, x and z axes are used for constructing the ellipse, and then the height is marked along in the y direction, and the corresponding ellipse is constructed at the other end. The common tangent at two ends are drawn. Suitable line types are used to represent the hidden edges. Now, cylinder resting on HP. For that, base ellipse is constructed first, and the height is marked along z axis, and the top ellipse is constructed and common tangents are drawn, and finish the drawing by using suitable line types. Now you got an overall idea and the basic concept of isometric projection. It will be more clear by doing this problem. The isometric view of a frustum of a square pyramid standing on horizontal plane on its larger base. Front view and top view are obtained. After that, starting from the horizontal line, marking the origin on that line, x-axis, y-axis and z-axis are indicated by using an indicator here, and we can mark 30-degree inclined line towards right, which will represent x-axis, and 30-degree inclined line towards left, which will represent y-axis, and a perpendicular line which will represent z-axis. Here I am selecting the leftmost corner as the origin point. It may vary depending upon the position of the object. Okay. The plan 1, 2, 3, 4. Corresponding points 1 and 2, 3 and 4 we can mark in the isometric plane. Here, this is the x-axis and this is the y-axis. So the origin point is point 2. Here, it is the joining point of x and y. So I am marking point 2 here, and from 2 I can mark point 4 here, which will be 40 millimeter away from point 2. Similarly, here point 3 can be marked along x-axis. I can mark point 3 here. Like that, I got all the points on the base. Now, the height of the frustum, which is 60 millimeter along the z-axis. So from elevation, I will get the height of the object, which can be marked along z-axis. So on each point from base, I am marking the distance z, which is 60 millimeter in the upward direction. And joining all the endpoints, I will get the top surface. But here I need the top dimension as a square of 20 mm. For that, I have to mark the center line on top, and 10 millimeter from center I am marking points. Through these points I can draw straight lines parallel to the edges. Now these points can be named as P, Q, R, S. Corresponding point P, Q, R, S will be obtained here at the top surface. Now I can join P to 1, Q to 2 like that for finishing the drawing. Then the visible edges are thickened by using thick line, and hidden edges are marked by using dotted line. Now the solution is over. Now we have to differentiate between isometric view and isometric projection. Isometric view is also known as isometric drawing. Isometric view, we are taking the same true dimension of the solid without using the isometric scale for reducing its dimension. The biggest visual difference between isometric view and isometric projection is the size of the two images. The isometric view or isometric drawing is drawn using true length, and in isometric projections, the height, width and depth are displayed at 82% of their true length. We are using isometric scale for drawing the isometric projection. So whenever you draw an isometric projection, you have to attach an isometric scale nearby the projection. Now you have to remember the following points while dimensioning isometric views or isometric projections. All the extension lines and dimension lines should be parallel to isometric axis, and they should lie on any of the isometric planes. The text should be placed at the middle of the dimension line after breaking it for a short length. The numerals placed along the three axes should be aligned with the direction of axis. These dimension lines should be aligned with any one of the x, y, z planes. Then the dimensional value should be marked by breaking the dimension line. These dimensional values should be readable from the directions in which it is looking. Then vertical z axis, it should be readable from right side. Okay. For drawing isometric projection or isometric view, there are two methods. One is box method and the other is coordinate method or offset method. We have the freedom of using any one of the method and a combination of box method and coordinate method, whatever it may be. In the box method, the object is assumed to be enclosed in a transparent rectangular box just to fit the object. Complete the isometric drawing of the transparent box using the isometric dimensions, either by using isometric scale or calculator, and marked along x, y, z directions from the origin. And the corners and edges of the solid are then located with reference to the edges of the box. While in the coordinate method or offset method, any one of the three isometric planes, namely the top plane or left plane or right plane, is taken as reference plane, and the end points of the edges of the object are marked along an axis perpendicular to this reference plane. This method is suitable for objects with large number of non-isometric lines and planes. For certain shapes, a combination of two methods may be used to complete the drawing in a shorter time. Now we can solve another problem of projection of frustum of pentagonal pyramid. First of all, finish the orthographic projections by using the given dimensions. And now the indicator diagram for different axes x, y and z are marked. Start from the baseline and mark x and y axis, which are 30-degree inclined to the baseline. Then the corresponding directions of x axis and y axis are marked at the left end of the plan. The entire plan is enclosed in a square named 1, 2, 3 and 4. First of all, I fixed the point 2 at the origin and then measure the distance between 2 and 1. Mark it here along y direction. Through 1, I can draw a line parallel to x axis, and the distance between 2 and 3 is measured and marked in the x direction. So I will get the point 4. Then I can draw another line which is parallel to 1, 2 to get the point 3. Now I know the distance between point A and B is 40 millimeter, and the distance between 2 and B is measured from here. Copy it to here and mark these points A and B along y-axis. Similarly, I can mark all these points on base and mark it as A, B, C, D and E. Now I can mark the dimensions in the Z direction. So from each point A, B, C, D and E, I can mark the height of the frustum, which is 60 millimeter, and I can join all these endpoints together to get the top surface. On this top surface, we have a pentagon with side 20 millimeter. So I have to mark 20 millimeter pentagon at the center of the top surface. Now I have to mark this 20 millimeter on the top surface, which is parallel to this line AB. Now I can mark 20 millimeter sides on the top surface and join all these together. I will get the pentagon on the top surface. Now I can connect the top and bottom using straight lines, and the hidden edges are represented by using dotted lines. Now in this example we can try the coordinate method of drawing isometric view. Draw the plan and elevation of the given pyramid, and section plane and intersecting points are noted. Then the corresponding points are marked in the sectioned plan. From this we will get the x, y, z coordinates required for drawing the isometric view. We are starting from the baseline, then the origin is selected, and 30-degree inclined x-axis and 30-degree inclined y-axis are drawn, and vertical line representing the z-axis are plotted. Here I am considering the point B as the origin point, so the x direction and y direction can be marked like this. Now we can identify the point C in the x-axis, point A in the y-axis, and point D, which is the intersecting point of parallel lines to x-axis and y-axis. On this side I am drawing a line parallel to AB, whose distance is equal to the distance between these two lines. Now I am drawing another parallel line at a distance of the gap between this DC and 3, 4. Now the intersecting points are noted. For locating the point 1, 2, 3 and 4 in the isometric view, I am marking this height of these points 1 dash, 2 dash and 3 dash, 4 dash in the z direction. So I can copy this distance at points corresponding to 1 and 2, and it is marked here, and the distance of the point 3 dash and 4 dash in the z direction is copied from here, and it is marked here and here to get the points 1, 2, 3 and 4. Now I can join all these points and finish the drawing by using proper line types. This surface 1, 2, 3, 4 indicates the sectioned surface, so we can hatch that one. Now you can dimension this figure by following the rules of dimensioning isometric views. Now the solution is over, and Next, we are going to discuss the isometric view of an irregular curve. Here, the plan and elevation are shown. I am enclosing the plan in a rectangle and identifying the origin. I already mentioned the origin should be carefully selected in such a way that the isometric view should expose maximum details. So that I selected the origin at this corner and marked y axis in this direction and x axis in this direction. I plotted the isometric view of the box and located the origin x, y and z in the downward direction. Located these points on the curve in the multi-view projection, and now I am going to locate these points in the multi-view drawing to the isometric view. For that, I need the x coordinate and y coordinate of this particular point and mark the same x coordinate and y coordinate in the isometric view. So here this point is transferred to here like this, and this end point is transferred to here. The x coordinate of this second point is marked here, and third point is located like this. Then fourth point is located. Then fifth point is located by corresponding x coordinate and y coordinate. Similarly, each point is located in the isometric view by taking the corresponding y coordinate and x coordinate. Now, I can join all these points together to get the curve on the top surface. For getting the corresponding point in the bottom, I have to mark the z coordinate of each point in the downward direction. Here I have to locate this indicator. Z is in the downward direction, so this thickness is copied to each point in the z direction for getting the depth of the curve. Now I got all these points, and by connecting all these points by using a smooth curve, I will get the isometric view of the curve. Okay. In university examination, generally they are providing the sheets with grids. A grid which includes all the three isometric axes will be very helpful in examination hall to finish these drawings quickly. It will be like this. X, Y, Z coordinates can be easily marked, and we can finish the drawing quickly. Okay. Thank you.